Stop marketing to the general public. Talk to enterprise AI builders. Your platform solves the hardest challenge in tech, getting secure, compliant AI into production at scale. But are you reaching the right 1%? AI Unraveled is the single destination for senior enterprise leaders, CTOs, vice presidents of engineering, and MLOs heads who need production-ready solutions like yours. They tune in for deep, uncompromised technical insight. We have reserved a limited number of mid-roll ad spots for companies focused on high-stakes, governed AI infrastructure. This is not spray-and-pray advertising. It is a direct line to your most valuable buyers. Don't wait for your competition to claim the remaining airtime. Secure your high-impact package immediately. Secure your mid-roll spot by emailing us at info@djamgatech.com. Back to today's show.
Okay, welcome back to the deep dive. So today we're doing something a little different. We're not looking at, a whole decade or something. We're actually zeroing in on just one single day, a really frantic 24 hours, actually.
Yeah.
October 8th, 2025. It's just this specific snapshot in time, but somehow it packed in breakthroughs in autonomy, biology, finance, even fundamental science. So our mission today is basically to sift through all this high-velocity stuff and pull out what you really need to know about, well, the future that's being built right now.
It really was a remarkable day. I mean, the speed of AI development, it's gone from a fast jog to just this relentless sprint, hasn't it? And if you want to get a handle on this new AI economy, you kind of have to grasp the scale, but also the sheer speed of all these things happening at once.
Right. Okay, let's try and unpack this straight away.
Sure.
Maybe start with two things that really grabbed headlines just to frame how fast this acceleration is. First off, the agent is really taking the wheel digitally. We saw the official details drop for Google DeepMind's Gemini 2.5 computer use model, which means AI agents aren't just like giving advice anymore. They're actually built to browse the web, complete tasks, complex multi-step tasks, by directly interacting with the UI.
Yeah, that capability is a major shift. It turns AI from, a passive helper into something that can actually do things operationally. And the money side of this, the kind of financial shock factor that goes along with that autonomy, it's just as huge. We saw these leaked reports start circulating about OpenAI's top customers. This group they're apparently calling the 1 trillion token club.
A token club. Wow. The name tells you something about the scale.
It really does. Assuming the list is accurate, it really shows how fast this specialized AI reasoning economy is forming. These are the companies paying, serious money to process absolutely massive amounts of data. They're essentially building the operational backbone for the next decade. And this list suggests these token wars are already kind of defining the four main types of companies that will dominate how AI gets used.
Okay, autonomy, these token wars, billions flying around. Let's start where the AI actually starts, getting out of the text box and taking control. Segment 1, autonomy and physical AI.
We definitely have to start with Gemini 2.5 computer use. The technical mechanism is really the key thing here. The agent doesn't just get text prompts, it actually operates through this continuous loop. It looks at a screenshot, could be a web page, could be a mobile app screen, then it figures out the single next UI action, like click this button, type this text, scroll down. And then, crucially, it gets a new screenshot showing the result, and the whole process repeats. It's literally mimicking how a human uses a computer, step by step.
That feels like a really significant jump in what AI can do. And the sources mentioned this model beat rivals, right? Like OpenAI's agent and Claude Sonnet 4.5.
Yeah.
But the immediate question, the one everyone asks, when an AI can directly control things, maybe sensitive accounts, it's got to be security.
Absolutely. That raises the biggest guardrail question. And Google did talk about this. They detailed this crucial safety mechanism. It's a per-step safety service. It reviews every single action the AI proposes before it executes it. Plus, developers get controls too, so they can demand user confirmation or just block certain high-risk actions altogether.
But hang on. A per-step review, is that really going to be enough? I mean, couldn't a smart bad actor just break down a malicious task into lots of tiny, seemingly harmless steps? Is that a real solution, or is it more like a temporary fix until the AI gets, smarter than the safety check?
That's a really interesting tension there. I think the consensus among researchers right now is that these per-step checks are probably the best defense we have against, accidental misuse or maybe low-level malicious stuff. They're designed to stop the AI from, say, hitting buy now unexpectedly or deleting a whole database without someone double-checking. But you're right, the long-term challenge is that adversarial planning, getting the AI to perform a malicious sequence of okay-looking actions. That's why those developer controls, the ones letting humans set hard boundaries or demand confirmation for specific sites or actions, they're arguably even more critical right now. It keeps the ultimate veto power with the user.
Okay, that makes sense. So it's like different layers of control. Now let's shift from digital actions to physical ones. The sources took us right into the Neuralink lab. We saw this footage of Nick Ray, the patient with ALS, actually controlling a robot arm using his brain chip.
Yeah, this is agency in the most literal sense, actually reclaiming physical control over the world. The system basically translates his brain signals into Bluetooth commands, and that lets him control a separate robot arm. And he wasn't just, moving a cursor around. He was doing complex, sequential, everyday things. Picking up a cup, putting on a hat pretty accurately, using a microwave, even driving his wheelchair slowly. These are tasks that need depth perception, planning sequences, fine motor skills. It's quite something.
And it seems like the big money, the capital markets, are really betting hard on this mix of AI and robotics. SoftBank's huge $5.4 billion purchase of ABB's robotics division, was that just a reaction to the Neuralink stuff, or were they already heading towards what they're calling physical AI?
I think they were already moving that way, but the Neuralink news definitely helps validate that strategy, right? Masayoshi Son at SoftBank is explicitly framing this big acquisition as a core bet on physical AI. For SoftBank, this is now like one of their 4 strategic pillars alongside ships, data centers, and energy that they think will define the future economy. It's a really clear signal. Major global finance sees AI plus physical robotics not as some niche thing, but as fundamental infrastructure. And that means deploying massive capital right now.
That massive capital deployment. That seems to be the thread running through this whole day we're looking at. Before we jump to the science breakthroughs, maybe let's tie the digital and physical autonomy back to something more everyday. The day also apparently saw a quick, practical tool launch for the creator economy, this new ChatGPT Canva integration.
Yeah, it's kind of the lower end, higher volume application of this agentic automation idea. You can now just give ChatGPT a simple text prompt, ask it to write and design, say, a professional looking 5-slide LinkedIn carousel. You pick a preset style, it pulls in the content, all within one interface.
Right, so if Gemini is automating complex research and transactions, this Canva thing is automating that more repetitive professional content churn. It shows this agentic AI idea is being layered onto basically everything, from tiny content tasks up to really complex web navigation.
Exactly. It's a perfect example of the whole spectrum of AI utility emerging.
Okay, let's pivot then. Segment 2. Let's look at AI's impact in really high-stakes areas, specifically health and core science. The sources pointed to Duke University's Tuna AI platform.
Right, Tuna AI. It combines robotics and machine learning specifically to design custom nanoparticles for drug delivery. And the results they reported were seriously compelling because it tackles one of the biggest bottlenecks in developing new medicines, just getting the drug to the right place in the body safely.
What were the actual numbers they reported?
So using these automated lab robots, the platform tested something like 1,275 different formulations. And it achieved a staggering 43% boost in successful nanoparticle creation compared to the old manual methods. Just think about that for a second. A 43% efficiency boost in a field where trials are famously slow, super expensive, and often fail just because the delivery method doesn't work.
And the real-world impact. They mentioned specific examples, right?
Yes, very tangible. They managed to successfully wrap a leukemia drug that's usually hard to deliver, made the particles dissolve better, kill more cancer cells. And in another example, for a different cancer treatment, they managed to cut a potentially toxic ingredient by 75%, while keeping it just as effective, at least in mice trials.
So why does that 43% boost suddenly make previously failed drugs viable again? What's the mechanism?
Yeah, the why is really important here. Tuna AI gets around a key limitation of how humans usually do this research. Often researchers have to tackle material selection, like what the particle's made of, or the mixing ratios, how you actually synthesize it kind of one variable at a time. It's slow. This AI approach, it handles both at the same time. It dramatically expands the number of options you can actually explore effectively. And that means AI could potentially rescue drugs that were shelved years ago, drugs that failed not because the medicine itself didn't work, but just because they couldn't figure out a safe or effective delivery system. It's solving a decades-old packaging problem.
That is staggering. AI isn't just speeding things up, it's cracking scientific logjams that have been stuck for ages. Okay, moving from medicine to core chemistry. The sources also gave this fascinating angle on the 2025 Nobel Chemistry Prize. It went to Omar Yaghi for his work on metal organic frameworks, or MOFs, and the reporting immediately tied this fundamental science breakthrough to how essential AI is now.
Absolutely. If you connect this to the bigger picture, like materials science for climate change, MOFs are these incredible ultra-porous crystals. People sometimes call them like a Hermione's handbag for molecules because they have this enormous internal surface area. They can selectively grab and store specific gases, like co-Euros for carbon capture or hydrogen for fuel. But designing the right MOF structure is incredibly complex. You're dealing with almost infinite possibilities, and that's where AI becomes totally indispensable for discovery at scale.
You mentioned these sources broke down 4 key ways AI is driving this MOF field right now. Let's slow down a bit and maybe unpack each one.
Yeah, let's do that. The overall umbrella concept here is inverse design at scale. So first, you've got inverse design itself. Instead of just testing materials you already have, generative AI models propose new MOF candidates by working backward from the properties you want. So say you need an MOF that's super efficient at storing hydrogen. The AI works backward from that goal to suggest the specific chemical structure you need. It cuts out huge amounts of trial and error.
Okay, so it's like asking for the blueprint directly instead of testing every possible way to stack the bricks.
Exactly like that. Second is fast property prediction. This uses tools like graph neural networks, GNNs. GNNs are great for these network structures like MOFs because they analyze the relationships between all the atoms, and they can quickly predict properties, absorption capacity, surface area, things like that without needing expensive, slow lab simulations for every single candidate. It lets scientists triage thousands of possibilities digitally.
Right, potentially shaving months, maybe even years off that early R&D phase.
For sure. And third, you move into the actual lab with self-driving labs. These are basically robotic platforms that use advanced optimization techniques, often something called Bayesian optimization. Think of it as a really smart, iterative guesswork system. The robot physically tries different synthesis conditions, changing the solvent, the temperature, the pressure. And the Bayesian optimizer uses the results of each experiment to intelligently decide the next experiment, automatically iterating to improve the yield or the properties.
Wow, so the robot is basically running its own optimized R&D cycle.
Precisely. And then finally, the fourth area is creating digital twins. These are machine learning models that simulate the entire process deployment. For example, modeling a whole direct air capture DAC column that uses these MOFs. This lets teams optimize the entire process virtually before they even start building the expensive physical hardware. That slashes construction costs and really speeds up getting things to scale.
That's incredible. It shows AI isn't just, making content faster. It's fundamentally changing the speed and even the scope of physical sciences that could impact huge things like climate and energy. Okay, let's shift gears now to the vision, the money, and the sort of macroeconomy picture, segment 3.
Yeah, we can probably start with the view from the top. Sam Altman's comments at Dev Day 2025 gave this really stark glimpse into where OpenAI, at least, sees the future of work heading.
His predictions were definitely provocative. He confirmed that AI is starting to show glimmers of novel discovery, not just summarizing what we know, but actually finding new knowledge. And he speculated the future of work may look less like work than it does now, which, that implies a massive shift in the whole social contract, right?
It does, but maybe the most stunning comment ties right back to that agentic progress we talked about earlier with Gemini. He claimed that the kind of capability we see in tools like Codex is actually not far away from being able to autonomously perform a whole week of human work. And that feeds directly into his ultimate provocation, the idea of a zero-person, billion-dollar startup entirely spun up by a prompt.
The automated company. Okay, but doesn't that vision kind of completely gloss over things like human trust, regulations, legal structure, sales, even if the AI writes the code and the initial product?
That's exactly the critical tension, isn't it, between the technological vision and the messy reality. Altman's statement is really about the feasibility of creation. The zero-person startup idea basically says the barrier to building the product itself is collapsing. But like you said, all the human interface stuff, getting VC funding, negotiating contracts, complying with GDPR, actually selling to other humans, that's the immediate bottleneck. So the vision confirms the tech might be almost ready, but the rest of the world, maybe not so much.
And that concept, that automated creation, it feels like the logical endpoint of this AI reasoning economy that's being built right now by those firms in the 1 trillion token club.
It absolutely is. It's really a tale of two AI economies happening at once. You've got, what, over 70% of ChatGPT use is apparently non-work stuff, personal writing, planning, getting advice. But then you have these massive customers processing trillions of tokens who are building the complex underlying intelligence systems that enable all that future automation. And the source material highlighted 4 key archetypes, 4 types of companies emerging from this token war that are really defining the market structure.
Okay, lay those 4 archetypes out for us. Why are these the dominant models?
Right. You can kind of think about it in terms of AI maturity stages, maybe. First, you have the AI native builders. Think companies like Cognition, Perplexity. They're right at the frontier, creating these advanced reasoning systems basically from scratch. They dominate the discovery phase. Then second, you have the AI integrators. These are the big established players like Shopify or Salesforce. They dominate the scaling phase. They layer sophisticated AI onto their existing platforms, wreaking huge customer bases quickly. Third, there's the AI infrastructure providers. These are the dev tool companies like Warp.dev or Datadog. They dominate the foundational layer, building the tools needed to reliably run, monitor, and secure these huge AI systems. And then fourth, you have the vertical AI solutions. Companies applying AI really deeply into one specific area, like a bridge in healthcare or a WHO in fitness. They dominate the application phase, proving that specialized intelligence can often beat general AI in complex, regulated, or niche markets.
And fueling this entire ecosystem build-out is just vast amounts of capital moving incredibly fast. We saw Nvidia putting $2 billion into Elon Musk's XAI,
Yeah.
but the way they structured that deal was, well, pretty unconventional.
Yeah, it was a fascinating bit of financial engineering, really designed purely to win the race for chips. So Nvidia invested the $2 billion in XAI equity, yes. But the arrangement used what's called a special purpose vehicle, an SPV. You can think of an SPV as just a dedicated shell company set up for one specific purpose. And this SPV was used to buy the specialized NVIDIA chips and then immediately lease them back to XAI over 5 years.
Okay, but why do it that way? Why not just have XAI take out a standard loan for the chips?
Because the traditional debt markets often aren't fast enough or flexible enough for the sheer speed and scale of this AI chip race, this unusual structure basically let XAI fund its massive Colossus 2 data center build-out without having to load up its main corporate balance sheet with debt. It's a really advanced financial maneuver designed purely to accelerate infrastructure build-out, prioritizing speed and getting guaranteed access to those crucial chips over maybe more conventional accounting.
And finally, just to round out this snapshot of the day, we have to touch on the security angle again. This was reported by OpenAI itself, right? Banning accounts linked to state-sponsored actors.
That's right. Impartial reporting here showed OpenAI took action against accounts linked to state actors in China and North Korea, specifically for misusing their models. The activities reported included things like using the AI models to help generate phishing emails, assisting with malware development, even drafting surveillance proposals.
And there was that very specific, quite chilling example mentioned about one of the Chinese groups, wasn't there?
Yes. One group was apparently caught using the models to help design social media monitoring systems, and, maybe most concerningly, something described as a high-risk, Eiger-related inflow warning model. But the key finding, the overarching point from OpenAI's investigation, seemed to be that these actors are mostly using AI to add speed and volume to their existing tactics. They weren't necessarily developing brand new types of attacks, but integrating AI to make their current workflows faster and more efficient. The value for them seems to be acceleration and scale more than radical innovation right now.
So that single day, October 8th, 2025, it really showed us this emerging future. You got AI agents gaining real control, both digitally and physically. You have massive amounts of capital flowing through these sometimes unconventional deals just to build the infrastructure faster. And you have AI cracking open scientific problems in medicine and materials that have been stuck for potentially decades.
The velocity is just unprecedented, isn't it? And the convergence, how all these things are happening together, that's the key. We heard Sam Altman suggesting that automating a whole week's worth of human work is not far away. So given that speed, that transition speed, and the rapid rise of these incredibly complex systems from, zero-person startups in theory to actual physical robots appearing in homes and labs, what are the really fundamental human skills? Not just the technical ones, but the core skills we'll need to adapt and, thrive alongside all this change in the coming decades.
That really feels like the core question we should all be thinking about now. It goes way beyond just resisting change or learning to code, doesn't it? It's asking what it really means to be fundamentally adaptable when the very foundations of work and maybe even discovery itself are shifting this incredibly quickly. Thanks for joining us for this deep dive.
Stop marketing to the general public. Talk to enterprise AI builders. Your platform solves the hardest challenge in tech, getting secure, compliant AI into production at scale. But are you reaching the right 1%? AI Unraveled is the single destination for senior enterprise leaders, CTOs, vice presidents of engineering, and MLOs heads who need production-ready solutions like yours. They tune in for deep, uncompromised technical insight. We have reserved a limited number of mid-roll ad spots for companies focused on high-stakes, governed AI infrastructure. This is not spray-and-pray advertising. It is a direct line to your most valuable buyers. Don't wait for your competition to claim the remaining airtime. Secure your high-impact package immediately. Secure your mid-roll spot by emailing us at info@dgamgaytech.com. Back to today's show.